Good morning and I welcome you students. As you see that we have told you in the first lecture how sound is produced. Can you tell me students how sound is produced? How sound is produced?
Sir, it is produced by the vibrating objects.
Vibrating. Any object which vibrates produces sound. You hit on a table, you hit on any object strongly and there are particles inside that. When they start vibrating, there will be vibrations and these vibrations will do what? These vibrations will then move. These vibrations will start moving. What will happen? The vibration will move from, you see, from the source to the receiver. There is a source and there is a receiver. These vibrations will move. And the result of that is there are compressions and rarefactions. We have told you sound travels in the form of compressions and rarefaction. Compression, then we have seen pressure, high pressure, low pressure, high pressure, low pressure. And compression means the particles come closer, density is more, and rarefaction means particles are less in a particular unit volume, the density becomes less. So we also said that we can consider that sound waves are nothing but the movement of variations in the densities of the particles or variation in pressures of the particles. That, and also we have told you last time, student, sound waves are what type of waves are sound waves? Mechanical waves. Question was asked to the student, what are mechanical waves, students? What are mechanical waves?
Sir, since sound waves are caused by the motion of vibrating particles, it is called as mechanical wave.
And the particles are not moving, they come back to the original position. You have seen, they come back to the equilibrium position. What is moving is a disturbance, is a wave. So sound is a wave. Now the question, next question naturally is asked by the students, that does the sound needs a medium to travel? Another question before you, everything we talk, question, answer. Does the sound needs a medium to travel? That is the next question. Can the sound travel without a medium? Now we have said sound is a mechanical wave and needs a material medium. Therefore, sound will need a material medium. Sound are mechanical waves. They are mechanical waves. So it will need medium. Some material should be there because these are the particles which are vibrating, and the particles are going to vibrate the next particle, neighboring particle, next particle. Like this, the vibrations will continue. So medium is required. And what medium we have right now? When I'm speaking, you are listening. What medium you have? You have air. This is the most common medium which is available. Then you can see that water is another liquid. There are sounds. Do you know the sound can travel in water also? Yes or no?
Yes, sir.
There is a swimming pool in which there is a music inside the water. So water. And then solids. This is a gas. This is a liquid. And you can have, for example, solid like steel. Steel is a solid. So the sound will need a medium. And if I say, if there is a vacuum, will the sound travel in vacuum?
No, sir.
Cannot travel. So sound cannot travel in vacuum. And that is one of the reasons. As you have seen, there are light energy reaching to us from the sun, but sound energies are not reaching because there will be vacuum in between. Then it will not be possible to move. The sound waves will not move in vacuum. Hence, they cannot travel the vacuum where there is no medium. Okay. The next question is definitely question number 1 was this. Now I'm talking of question number 2, students. We says demonstrate. You have to perform an experiment or activity. Perform an activity or an experiment to prove that sound needs a medium to travel, or sound cannot travel in vacuum. Experiment to show that sound cannot travel in vacuum. We can do this activity in your science lab, in your physics lab. Let us see how experiment can be done. Okay, students, in the NCERT book, he has given a diagram to us. Let us see what it is. Give an experiment to show that sound needs a material. What we are saying, sound needs a material medium to travel. Sound is a mechanical wave. Again and again, these things are repeated. Very, very important questions. And MCQ, another type of question, such questions will be there. Sound needs material. And you are saying that is a mechanical wave. So mechanical wave needs material medium to travel. It can travel through air, water, steel, but cannot travel in vacuum. Can we demonstrate this? The answer is yes. Let us see what experiments is being done, student. This is called bell jar experiment. This is a, you can see what we have created here. It is a bell. There is a bell. Is a bell, student? Electric bell. Electric bell. Can you see the electric bell?
Yes, sir.
This is a jar. Jar which is covering the bell. Bell jar. Can you see the bell jar?
Yes, sir.
Jar. Okay. Cork. This is a cork. We can see the cork. This is a switch. In electric circuit, switch is required if you want to switch on. An electric connection. So there is electric connection and a switch. And what is inside this bell jar? Students, what is inside the bell jar? Air. This
Yes, sir.
jar, if I have any jar, what it will contain? It contains the air. So when you start the experiment in the bell jar, we are having air. We have air. Now what do you do? First thing, complete the circuit. Okay? Close the circuit. What means switch on? What will happen? The bell will ring. And you will be able to listen. Can you listen the sound?
Yes, sir.
Listen the sound. Listen the sound of the bell. What will you? Can you see there is a vacuum pump? There is a vacuum pump attached to this. Vacuum pump. What the vacuum pump will do?
Remove air from the jar.
It will remove air from the jar. So as slowly and slowly you apply the vacuum, the air is being removed. What will be the result of this? The circuit is still complete. As air is being removed, the material is becoming less air. Concentration is decreasing. Then what will happen? The sound of the bell that starts becoming feeble, weak. Okay? Weak, weaker. And what will happen when all air is removed? By the bell jar, by the vacuum pump. Will you be able to listen any sound?
No, sir.
So no sound is heard. Does that mean bell is not working?
No, sir.
Bell is working. Bell, the circuit is complete. Bell is already working, but the sound is not reaching. Sound is not reaching our ear. It is not that the sound is not there. Sound is there. Sound is being produced by the bell, but it is not reaching because right now what happened? There are no medium particles. And when the medium particles are not there, sound cannot travel. And when sound cannot travel, what will be the result? That the vibrations will not take place in this bell jar, which will start vibrating the particles of the medium. And then that is how we are able to listen. So sound is not, no sound is heard, I am saying. Though sound is produced. Clear? Sound is produced but not heard.
Yes,
Bell
sir.
is ringing. Bell is ringing, students. But we do not hear the sound. Bell is ringing, but sound cannot travel in vacuum. Therefore, we do not hear the sound. What we are trying to say, student, this is an important experiment. Such questions they ask in the exam. When we turn on the switch, we hear the sound of the bell. Now we pump out the air from jar gradually with the help of a vacuum pump. Sound becomes fainter. When most of the air has been removed, we hear a very feeble sound. When there is inside in the jar, sound travels through it to the wall of the jar. This makes the wall to vibrate, which in turn sends us sound to us. When air is removed, sound from bell cannot travel to the wall of the jar. Hence, no sound is heard. Therefore, what is the result? What these are the observations. Observation, you have done an activity. So for the activity, you need the apparatus, which you have seen what the bell jar, circuit, electrical circuit, and the vacuum pump. All this was used. Then you have made the observations. Every experiment, you have observations, whatever we have written. And then what is the conclusion? What conclusion? You can say.
Sound doesn't travel in vacuum.
So this proves that sound does not travel in vacuum. Needs material, medium like air, which is gas, solid. Solid can be, you can say iron or any steel. Okay? Air or liquid like water. Okay? To travel. All right, this activity was given in the book. A question is there till what we studied, student. Number one question before you on the screen. You have 1 to 2 minutes to answer the question. Explain how sound is produced by your school bell. You have seen a school bell. What is it made up of? This bell. What is this bell, student? This is a metallic disc. What happens? This is a sport. What do? You will have a hammer. ठीक है, wooden hammer, and strike it. Strike the wooden hammer. What is the result of that? Tell me.
So sound will be produced.
Why that is saying we know sound is produced. How the sound is produced? What answer
Sir,
you will?
because of the vibration of a metallic disc.
Metallic disc vibration. Or
Because
but the question is, you know the answer, but how you write the answer is important. When you hit the hammer, solid, this is wooden hammer, on this, what will happen? This disc is made up of what? There are particles in the metallic disc. The metallic disc is made up of particles, tiny particles. And what will happen when you will hit? These tiny particles will start vibrating. Okay?
yes, sir.
The particles of the school bell, what happens? That is the disc starts vibrating. What will be the result? So they are vibrating, then what will happen? The particles will start vibrating. Okay? As a result of vibrations of particles, what will happen? Sound will be produced. First thing we told you how the sound is produced. That question is based on this. When particles vibrate, it will produce. Any particles which vibrate produce sound. I am clapping. How the sound is produced? There are particles. The particles have started vibrating, and then they will send the vibrations through the medium disturbance, and then the sound propagates. So this is question is how it is produced. He is not asked how it is propagated, right?
Yes, sir.
Produced. So read the question and word carefully. If I says how the sound is produced, students are saying sound is produced by compression and rarefaction. That is the way it propagates, not produced. If the question is how the sound propagates, question 2, if I put how sound propagates, now what is your answer? This question and this question are different. If say how the sound propagates from an electric bell, from the school bell. If I put the question how sound propagates from your school bell. Okay? What do you will answer?
Because of compression and rarefaction.
And it travels as a wave, as a disturbance in the form of compression and rarefaction from the source, from the bell to the receiver, which is our ear. Okay? We have already answered the question, but just I wanted to tell you that read the word carefully and then answer. It propagates. Okay? Through air. Through air. Air is the medium. Material medium. Okay? In series of compressions and rarefactions. Got the answer? Be careful.
Yes, sir.
Sometimes we know the answer, we don't write what is asked in the question. That is the reason we. Question number 2 is a favorite question in the paper, student. They will ask you many times, why are sound waves called mechanical waves? So many times you answer the question. What answer you are giving? Only 1 minute.
Sir, because in sound waves, the vibrating particles are in motion. So, sir, it is known as mechanical wave.
Vibrating sound is produced by the vibration of the particles. Vibration of the particles. And they need a medium to travel. Okay? You are saying sound is produced by the vibrations of particles and particles need a material medium like gas, liquid, solid, okay, to propagate. Hence, therefore, they are mechanical wave. You can see I am trying to write in points. What is the reason? It helps. It is easier and the chances of mistakes become less. Writing bigger paragraphs, you say, students, is not advisable in the papers for any question. You will, even when you solve numericals, what we have done, we have shown steps 1, 2, 3, 4, 5 like this. It makes easier, and for examiner, it is easier to grade your paper easily, and he will check it fast. Another question is coming before the screen, students. Question answers help us to understand the subject more thoroughly. Suppose you and your friend are on the moon. Will you be able to hear any sound produced by your friend? You have 1 to 2 minutes to answer the question, students.
No, sir, we will not be able to hear.
First, you are saying no. No, will you be able to hear any sound produced by friend? No, I will not be able to hear the sound produced by my friend. Why, my friend? Why?
Because, sir, in space, there is a vacuum. So, since there are no particles for vibration, therefore we won't be able to hear.
Both of you are on the moon. Where we said? Am I saying I'm on Earth and my friend is on moon? You know the answer, but you don't know how to write the answer. That is the reason I'm taking some time. What is the reason? On the moon, if I complete it. Now, what is the second? What is the reason why you can't hear? If you are on the moon, your friend is also on the moon. Now you say you cannot hear. What answer you are giving?
Sir, because there is no medium for sound to travel.
There is no atmosphere, you are saying, or there is no medium. Okay? On the moon. Okay? To propagate the sound. Is it clear?
Yes, sir.
अरे sound तो produce हो रहा है ना. You are talking sound, you are producing, but sound is not reaching, is sound not able to propagate because there is no atmosphere. If atmosphere is there, then what will happen? And naturally the sound will travel. Atmosphere क्या है? जो भी gases है, medium. Atmosphere कौन सा आपका atmosphere है? This medium is gases. Whatever you say, material. Further, more important information. Question is, again I am talking of question answers all the time, students. Why sound waves are longitudinal waves? What are longitudinal waves, student? Now I said they are transversal waves. Now we are saying longitudinal. Long means what? Lengthwise. They're traveling like this. There is you are saying sound is propagated in the form of a disturbance like a wave. Now which is the direction of the wave? Where the wave is traveling and how the particles are vibrating. You are seeing compressions and rarefactions.
Yes, sir.
The sound waves in air and any fluid medium are longitudinal waves because the particles of the medium through which sound is transported, particles of the medium, okay, through which it is propagated, vibrate parallel to the direction of motion of sound waves. To the direction of motion of sound wave. पार्टिकल्स जो है एक परपेंडिकुलर होता है, जैसे ये है, देखो, if this is there, that if I vibrate up and down to this, what is this? Perpendicular. If this is a particle, ठीक है, ये perpendicular है, ये perpendicular है, और ये जो होता है, if अगर ये vibrate करे this and this way, ये particle vibrate कर रहा है, what is this? And if direction is like this, direction of the energy or wave is like this, तो ये क्या है? इसके perpendicular और parallel? Parallel है. तो ये जो particles हैं, they are vibrating parallel, और ये जब up and down होता है, ठीक है, वो क्या होते हैं? परपेंडिकुलर. वाटर वेव्स में क्या हुआ था? वाटर में स्टोन आपने फेंका था, तो वो क्या कर रहे थे? पार्टिकल्स वाइब्रेटिंग अप एंड डाउन. बोलो.
Yes, sir.
वाटर वेव्स वर दे वर कॉल्ड, उनको क्या बोला था? ट्रांसवर्सल.
Yes, sir.
ये क्या है? पार्टिकल्स आर वाइब्रेटिंग, पार्टिकल्स आर वाइब्रेटिंग, दीज पार्टिकल्स आर वाइब्रेटिंग. ये इसकी मेन पोजीशन थी. नेक्स्ट पार्टिकल था, दिस वाज द मेन पोजीशन. ये भी, ये कैसे सब पार्टिकल वाइब्रेट कर रहे हैं, और डायरेक्शन ऑफ द वेव क्या है? सेम. एनर्जी डायरेक्शन क्या है? इधर से जा रही है, सोर्स से. ये कोई सोर्स है और यहाँ पे रिसीवर है. ये आपका ईयर है सपोजिंग. तो क्या हो रहा है कि पार्टिकल्स आर वाइब्रेटिंग पैरेलल टू द डायरेक्शन ऑफ द साउंड वेव्स, देन दे आर कॉल्ड longitudinal waves. So there are back and forth vibrations, and each particle is transmitting this vibration to the next particle back and forth, and comes back to the same equilibrium position, parallel to the direction of the wave. तो अगर जो सोर्स है, वो सोर्स के पार्टिकल्स हैं, वो लेफ्ट टू राइट मूव कर रहे हैं, तो आप देख रहे हैं कि क्या पैरेलल हैं. and this is reaching the final receiving end. यहां पर एग्जांपल देख लीजिए क्या हो रहा है. ये स्प्रिंग है, ठीक है. स्प्रिंग देखा आपने?
Yes, sir.
तो ये इसको हमने फिक्स कर दिया एक साइड पर. नाउ यू कैन कंप्रेस द स्प्रिंग. इसको आपने कंप्रेस कर दिया और छोड़ दिया तो क्या होगा? या इसको आपने स्ट्रेच कर दिया, आपने इसको खींच दिया, ये आप इधर से स्ट्रेच कर दिया तो अब क्या होगा? तो आप देख रहे हैं कि ये आप जो किस तरह के होते हैं, ऐसे कंप्रेशन बन जाते हैं और रेरिफैक्शंस ट्रांसफर होते हैं. कंप्रेशन रेरिफैक्शन, कंप्रेशन रेरिफैक्शन. तो कंप्रेशन और रेरिफैक्शंस जो होंगे तो ये ट्रेवल करते हैं, ये ट्रेवल करते हैं. तो दे आर, जो पार्टिकल्स थे उसके वो वाइब्रेट कर रहे हैं पैरेलल, ठीक है, और एनर्जी जो ट्रांसफर हो रही है. तो कॉइल्स जो है वो लेफ्ट एंड राइट मूव करते हैं. कॉइल्स लेफ्ट राइट ऐसे लेफ्ट राइट ये वाइब्रेशंस हो रही हैं. तो दीज वाइब्रेशंस आर पैरेलल टू द डायरेक्शन इन विच द वेव इज अंडरगोइंग प्रोपेगेशन. तो ऐसी वेव्स को क्या बोलते हैं? लॉन्गिट्यूडनल. तो ये एक्टिविटी आपकी बुक में ही दी है उसने. टेक ए स्लिंकी, आस्क योर फ्रेंड टू होल्ड वन एंड यू होल्ड द अदर एंड. नाउ स्ट्रेच द स्लिंकी, ठीक है, एज शोन इन फिगर 12.7. देन गिव इट शार्प पुश टुवर्ड्स योर फ्रेंड. तो ये देख रहे हैं आपने, होल्ड किया है ए और ये बी, इसको शार्प पुश दिया है. What do you notice if you move your hand pushing and pulling the slinky alternatively? What you observe? If you mark a dot on the slinky, you will observe that dot on the slinky will move back and forth parallel to the direction of the propagation of the disturbance. तो इसके कोई पॉइंट को मार्क कर लो आप कलर से, ठीक है. तो क्या होगा कि what you will observe कि वो जो डॉट है वो बैक एंड फोर्थ मूव करता है पैरेलल टू द डायरेक्शन ऑफ द propagation of the wave. Dot on the slinky will move back and forth parallel to the direction of the propagation of disturbance. तो जो भी डिस्टर्बेंस हो रही है, पार्टिकल्स क्या कर रहे हैं? वाइब्रेटिंग पैरेलल टू द, पार्टिकल्स जो हैं स्टूडेंट्स, दे आर वाइब्रेटिंग पैरेलल, ठीक है, टू द डायरेक्शन ऑफ प्रोपेगेशन, ऑफ द वेव और डिस्टर्बेंस. तो ये एक्टिविटी यू कैन डू इट. तो इसी को हम क्या बोलते हैं? क्या प्रोड्यूस हो गया?
Longitudinal waves.
तो लॉन्गिट्यूडनल वेव प्रोड्यूस हो गई. तो साउंड वेव जो है वो किस टाइप की वेव्स है?
Longitudinal waves.
जो वाटर वेव्स प्रोड्यूस हुई थी, वाटर वेव्स में क्या हुआ था?
Transverse waves.
तो वाटर वेव्स जैसे होती हैं, ये आपका पाउंड ऑफ वाटर है, यहां पर आपने स्टोन फेंका स्टूडेंट, तो वेव्स कैसे बनी थी? ये इस तरह से ट्रांसमिट हुई थी डिस्टर्बेंस, और ये पार्टिकल कैसे जा रहा था? ये पार्टिकल की मोशन है. तो बताओ ये पार्टिकल क्या पैरेलल वाइब्रेट कर रहा है इसके?
No, sir.
तो वो परपेंडिकुलर है. तो ये इनको बोला था हमने ट्रांसवर्सल वेव्स, ठीक है. ये जस्ट टू शो यू द डिफरेंस दिख रहा है हमें, ठीक है.
Yes, sir.
ओके.
Sir, transversal waves occur only in liquid.
We will talk about that right now. The chapter is sound wave, लेकिन वैसे आपको एग्जांपल दिया.
Okay.
वो सारे भी धीरे धीरे और पढ़ेंगे. more but I give you more information than is given the book just to make a comparison कि आपको पता लग जाए कि ये आपके बुक में नहीं है. हमने इसको जस्ट दिया आपको इसलिए what type of waves are there we will learn. अब क्या हुआ कि longitudinal waves जो होती हैं स्टूडेंट basically consisting of a periodic disturbance or vibration that takes place in the same direction as the advance of the wave. देखो ये जो मैं बोल्ड लेटर्स डालता हूँ स्टूडेंट, दे आर इंपॉर्टेंट, क्योंकि जो क्वेश्चन आजकल बन जाते हैं ना, जैसे असर्शन रीजन क्वेश्चंस बनते हैं, देखा आपने?
Yes, sir.
तो in such questions students they can take up a line and put it, and sometimes what they do, they will change one word in that line and you will be tricked कि whether the statement is ये statement है, it is a statement. So statements are given in such question. So first thing is to find whether the statement is true or false, right or wrong. ठीक है, true है या false है. So what they do, they will just take up one word or something and put it. You will think it is true, but then they have removed some word. तो ये this is the reason we have to be careful कि ये जो मैं definitions बता रहा हूँ important है, इनको note करो. And you are getting recorded videos, you can watch them again, no problem. So these are very important and information. Not only they are definitions, but you have to see what statement we are writing, word by word, lines, each line, each word. I remove one word, the meaning changes. So be careful. The combined motion result in advance of alternating regions of compressions and rarefactions in the direction. What is happening? The result is here we have shown a picture more. There are alternate compressions and rarefaction. Alternate ये compression बनाए तो फिर देख रहे हैं आप इस तरह से ये travel करता है. Alternate compressions and rarefactions. ये नजदीक आ गया, ये थोड़ा दूर है, ये और नजदीक हो गया, ये दूर हो गया. इस तरह से हर जगह पर आप देख रहे हैं ये कंप्रेस हो रहा है, ये रेरिफाई हो रहा है. तो एक तरीके से ये एक तरीके से वेव्स ही चले जाते हैं. डिस्टर्बेंस जो है, इट इज ए टाइप ऑफ डिस्टर्बेंस. यू विल लर्न मोर अबाउट दिस इन व्हेन यू विल टेक फिजिक्स क्लास फॉर 11th क्लास एंड दैट यू विल लर्न मोर अबाउट दिस. सो वेव मोशन क्या होती है सारी, दे आर कमिंग इन फिजिक्स टॉपिक इन कंप्लीट डिटेल, just to show you a picture of how this disturbance or wave is traveling. Alternating regions of compression and rarefactions are produced in the direction of the propagation of the wave. To give a more explanation, the regions where the regions where coils become closer are called compressions. तो coils जहां नजदीक आ गई वो compressions हैं. ये सी दिख रहे हैं आपको, compression. ठीक है. coils are farther apart are called, ये coils जो हैं आपकी farther apart है.
Yes, sir.
Farther apart, they are called rarefaction. यहाँ पे जो coils हैं, they are region, they are closer. ठीक है. coils become closer, so they are called compressions. So as we already know, sound propagates in the medium as a series of compressions and rarefactions. So sound कैसे travel करती है? Series of compressions and rarefactions. Yes, important line, you know, assertion reason में such lines are produced that sound travels as series of compressions and rarefactions. Now we can compare the propagation of disturbance linked with sound propagation in the medium. These waves are called longitudinal waves. In these waves, individual particles of the medium move in direction parallel to the direction of propagation of the disturbance. Particles do not move from one place to another. Important, बार-बार ये कह रहा हूँ. Particles do not move. ठीक है? Do not move from one place to another place. From one place to another place ठीक है, बट बट ऑसिलेट और वाइब्रेट, ऑसिलेट और वाइब्रेट, ठीक है, ये वाइब्रेट करते हैं और कुछ नहीं करते, ऑसिलेट और वाइब्रेट, ठीक है। अबाउट आई कैन से मीन पोजीशन, एक पोजीशन है जो उनकी उसके अराउंड वो वाइब्रेट करते हैं, एंड दिस इज हाउ साउंड वेव्स प्रोपेगेट्स, हेंस साउंड वेव्स आर लॉन्गिट्यूडिनल वेव्स। तो क्वेश्चन ये उसने पूछा, शो साउंड वेव्स आर लॉन्गिट्यूडिनल वेव्स। तो ये आपके सामने एक्टिविटी है, एक्सपेरिमेंट है। साउंड वेव भी ऐसे ट्रेवल करते हैं, और ये जो स्लिंकी जो हमने शो किया है, इट इज आल्सो हैविंग सीरीज ऑफ कंप्रेशन एंड रेरिफैक्शंस। तो आप इसके मार्क कर सकते हैं किसी भी पार्टिकल को, यहाँ पर कलर से, आपने कोई कलर से मार्क कर दिया तो वो क्या दिखेगा कि सेम पोजीशन पर ही दिखेगा आफ्टर ऑल दिस, लेकिन वो वाइब्रेट करा था, क्या हुआ था, वाइब्रेशन हुई थी उसकी, पोजीशन चेंज नहीं होगी एंड में। अब यहाँ पर हमने बता दिया आपको कि transverse waves are one in which individual particles of the medium move about their mean position and direction perpendicular to the direction of the, ये बता दिया था अभी मैंने एग्जांपल दिया था, कौन सा दिया था, वाटर वेव्स।
Yes, sir.
The waves produced by moving one end of a long spring up and down rapidly, whose other end is fixed. These, the water waves or ripples formed on the surface of water in a pond are examples of this. वाटर वेव्स जो फॉर्म होती है, अगर आपने द वेव प्रोड्यूस्ड बाय मूविंग वन एंड ऑफ ए लॉन्ग स्प्रिंग अप एंड डाउन रैपिडली, अगर इसका कोई एंड फिक्स कर दिया, तो यहाँ पर जब आपने इसको ऐसे हाथ से प्लग कर दिया, जो वायर्स होती हैं जैसे फिक्स्ड होती हैं किसी इंस्ट्रूमेंट पे, आप उन्हें प्लग करते हैं तो वो ऐसे ऐसे मूव करते हैं, तो और ये साउंड और जो डिस्टर्बेंस है वो ऐसे जाती है। तो ऐसी जो वेव्स हमने बताई थी ये ट्रांसवर्सल वेव्स हैं। ट्रांसवर्स आर क्रिएटेड व्हेन मोशन परपेंडिकुलर टू द प्रोपेगेशन ऑफ वेव इज प्रोड्यूस्ड इन द मॉलिक्यूल दैट ऑफ द मीडियम। इस तरह से इनमें हमने वेव क्या है, ये वेव वी हैव शोन व्हाट इज द वेव हियर, इट इज ट्रेवलिंग इन द फॉर्म ऑफ, यू कैन सी देयर इज ए क्रस्ट ट्रफ। तो एक एम्पलीट्यूड, इसे एम्पलीट्यूड अभी ये एक्सप्लेन करेंगे कैरेक्टरिस्टिक्स ऑफ द वेव्स में, बट ये वेव इस तरह से हमने दिखाई है। इसमें वी हैव शोन यू एम्पलीट्यूड, और ये वेवलेंथ दिखाया है, और इस तरह से ये मूव कर रही है इन द फॉर्म ऑफ क्रेस्ट एंड ट्रफ्स बने हुए। तो मोर ऑफ दिस विल बी एक्सप्लेन्ड लेटर। अब क्वेश्चन आ गया आपको ये कि ये व्हाट आर लाइट वेव्स, अब बताओ कि लाइट की वेव्स क्या होती है, व्हाट डू यू नो अबाउट लाइट वेव्स। तो कोई पूछे आपसे लाइट वेव्स क्या है, लाइट वेव्स अभी तक आपने वन टाइप ऑफ वेव्स यू स्टडी की, आपने पढ़ा कि लॉन्गिट्यूडिनल वेव पढ़ ली, ट्रांसवर्सल वेव भी देख ली, और मैकेनिकल वेव्स भी देख ली। अब लाइट क्या है, विच वेव इज लाइट, लाइट इज अ वेरी स्पेशल टाइप ऑफ वेव, very important point. This in more detail you will study in when you opt for physics science, students will study more about this। 11th क्लास में पूरा चैप्टर है इलेक्ट्रोमैग्नेटिक वेव्स पे। देखो कि लाइट के बारे में वैसे बता रहा हूँ, लाइट इज एन इलेक्ट्रोमैग्नेटिक वेव। व्हाट इज इलेक्ट्रिक, यू हैव सीन इलेक्ट्रिक कंपोनेंट भी है और मैग्नेटिक भी है। क्या है, इलेक्ट्रिक एंड मैग्नेटिक कंपोनेंट्स। द वेव्स ऑफ एनर्जी इज एनर्जी, जो लाइट आ रही है आपके पास, और ये सब इलेक्ट्रोमैग्नेटिक वेव्स हैं। आपको पता है इंफ्रारेड कितने रीजन्स हैं इसके, दैट आल्सो यू विल सी। द वेव्स ऑफ एनर्जी आर कॉल्ड इलेक्ट्रोमैग्नेटिक वेव्स, EM, बिकॉज दे हैव ऑसिलेटिंग इलेक्ट्रिक एंड मैग्नेटिक फील्ड्स होते हैं। इनमें क्या होते हैं, इलेक्ट्रिक एंड मैग्नेटिक फील्ड्स होते हैं, which are oscillating ऑल इलेक्ट्रोमैग्नेटिक एनर्जी वेव्स ट्रेवल एट द स्पीड ऑफ लाइट, और इनकी जो स्पीड होती है वो स्पीड ऑफ लाइट होती है। स्पीड ऑफ लाइट, व्हाट इज द स्पीड ऑफ लाइट? कुछ आइडिया है आपको? स्पीड ऑफ लाइट
3 × 10⁸
मीटर पर सेकेंड यू आर सेइंग इन एयर, ये वैक्यूम में। तो जो स्पीड ऑफ लाइट है वैक्यूम में, मान लो 3 × 10⁸ मीटर पर सेकेंड है। नो मैटर इनकी whatever different types of electromagnetic waves are there, different types of electromagnetic waves are with the different wavelength और frequencies। आपने पढ़ा कि कितने फ्रीक्वेंसी पे चल रहा, फ्रीक्वेंसीज होती हैं जिसपे आप वेव्स कैच करते हो। जब आप सुनते भी हो कोई प्रोग्राम, लिखा है ना कितने फ्रीक्वेंसी पे चल रहा, डिफरेंट फ्रीक्वेंसीज पे आपके जो भी रेडियो भी सुन रहे हो तो फ्रीक्वेंसीज है ना उसमें। तो ये
yes sir
वेव्स हैं जो कैच होती हैं और दे हैव डिफरेंट फ्रीक्वेंसी, बट इनकी जो स्पीड है वो क्या कह रहा है, सेम है एज द स्पीड ऑफ लाइट। ये सब सेम स्पीड पे चलते हैं। तो इलेक्ट्रोमैग्नेटिक वेव्स डू नॉट रिप्रेजेंट फिजिकल डिस्प्लेसमेंट्स दैट प्रोपेगेट्स थ्रू ए मीडियम लाइक ए मैकेनिकल साउंड एंड वाटर वेव। ना तो ये मैकेनिकल साउंड वेव्स है ना वाटर वेव्स की तरह है, ठीक है, क्योंकि उनमें आपको मटेरियल मीडियम के पार्टिकल्स की नीड पड़ी थी। क्या पड़ा था? मटेरियल पार्टिकल्स वाइब्रेट कर रहे थे, या तो पैरेलल और परपेंडिकुलर, यही हो रहा था ना। पार्टिकल्स जो थे
yes sir
वो आप कह रहे हो वाइब्रेट कर रहे थे, या तो परपेंडिकुलर थे और पैरेलल थे टू द डायरेक्शन ऑफ द प्रोपेगेशन ऑफ द वेव। लेकिन यहां पर तो ये नहीं है। Instead describing propagating oscillation in strengths of electric and magnetic field। तो यहाँ पर इलेक्ट्रिक और मैग्नेटिक फील्ड्स जो होते हैं वो प्रोपेगेट करते हैं। इनको क्या बोलते हैं? इलेक्ट्रोमैग्नेटिक वेव्स। जितने all electromagnetic waves you see, they will have electric and magnetic components, electric fields and magnetic fields, and they will travel with the speed of light, जो भी वैक्यूम में हमने बताई है 3 × 10⁸ मीटर पर सेकेंड। See the differences between different type of waves. As I said, now we have learned a lot of information about the various types of waves and what are the sound, because that chapter which we are studying is sound wave. So what are the characteristics of the sound waves? We have told you how do we are representing a disturbance or a wave. You have seen the pictures of series of compressions and rarefactions. Any wave has certain characteristics. We are talking of some 5 characteristics of them. What is that? Wavelength, amplitude, time period, frequency, velocity. तो ये 5 टाइप की वेव्स हैं, characteristics of the waves के। कौन कौन से? Wavelength, amplitude and time period and frequency। तो इनकी पूरी डिटेल्स जो फिर है हम नेक्स्ट क्लास में डिस्कस करेंगे। ये पूरा टॉपिक है, पूरा चैप्टर है इसके ऊपर। तो वी आर गोइंग टू डिस्कस इन द नेक्स्ट क्लास अबाउट दिस। बेसिकली व्हाट वी हैव सेड बाय नाउ, व्हाट इज द की concept board or key takeaway? What we have proved that sound needs a medium to travel. Without medium, sound cannot travel. And the mediums can be solid, liquid or gas. Then you studied that sound waves are mechanical waves. The reason and important, they are longitudinal waves. And then we also told you what is the difference between longitudinal and transversal waves. And further, what you have seen, that what is what are electromagnetic waves. They will be discussed in more details as we will go for physics in 11th class. Therefore, we will continue next time. What are the various characteristics, and some numericals could be there on that also in the next class. All right. Then I will meet you in the next class. Okay. Bye-bye.
Thank you, sir.